Hello everyone. Today I will be discussing the fourth rule of equation reducible to exactness. Now, what is rule 4 trying to explain? The rule 4 says that if you are given a differential equation of this form, that this differential equation must be homogeneous. And when the differential equation is homogeneous, then our integrating factor will be 1 divided by ms plus ny. Now, when do we say a differential equation or a function is homogeneous? A function is said to be homogeneous of degree n if f, a function of t of s and t of y, is given as t raised to power n, the function of s and y. Now, let us demonstrate an example of a differential equation that is homogeneous. Now, look at this example 1. We are given x squared y ds minus s cubed plus y cubed dy equals 0. Now, the first thing we are going to show is to show if this differential equation is homogeneous or not. Now, let's test this. Now, look at this is x squared. Then we write our t squared. It is x squared. We are writing t squared because the question itself is x squared. S squared. So there's a multiplication between x squared and y. Dot. What's our y? Y is just an invisible one. It has an invisible one. So this will be t1 y raised to power 1 all the s minus, we have our s cube. So the t that we are going to introduce will be t cube. We have t cube s raised to power 3 plus t cube y raised to power 3 all equal to 0. My mission here is to show that the differential equation is exact. Now, if you look at this, t squared and t, from the law of indices, our t will be raised to power 3 s squared y all the s minus t cube is common to both, so we take it as 1. Then we have s cube plus y cube all equal to 0. So t cube s squared y minus t cube s cube plus y cube is equal to 0. Now, if you look at the left hand side and the right hand side, what do you have? You have a common value, which is t cube. So our t cube here can be written as x squared y minus x cube plus y cube all equal to 0. Now, the question is now what? It's homogeneous because t cube is present here and t cube is present here. It shows that the differential equation 1, it shows that the differential equation here is what? Is homogeneous. And if it's homogeneous, then we can solve this problem using this procedure. Now, let's solve the problem itself. Now, on solving this problem, the first thing we are going to since it is homogeneous, the first thing we are going to consider is to find the integrating factor of this form. Now, the first thing we are going to do is to find our ms plus ny. So the whole of this is our m. So multiply it by s. We have s cube y plus, what's our n? We have n here. Multiply the whole of n by y. Don't forget, because of this negative sign, we have minus s cube minus y cube. Because of this negative sign. Multiply that by y. We have s cube y minus y raised to power 4. So s cube y, yes, this is minus s cube y minus y raised to power 4. So this we cancel out. We are left with minus y raised to power 4. So if we have minus y raised to power 4, then our integrating factor if will be equal to 1 all over what? 1 all over ms plus ny. That will give us 1 all over minus 1 all over y raised to power 4. So our integrating factor is minus 1 over y raised to power 4. Now, we are going to use this integrating factor to multiply each of these terms here and here. Now, let me rub this off. Don't forget our integrating factor is minus 1 over y raised to power 4. So let me use this to multiply each of the value we have there. Understand? Okay. So our integrating factor is what? Minus 1 over y raised to power 4. So let's divide the whole of this. So we have x squared y divided by, don't forget, minus y raised to power 4 all the s minus s cube divided by y raised to power 4. Now, this is minus. We have minus here from the question, so we have minus s cube over y raised to power 4. There's a negative sign here. We also have plus y raised to power 3 divided by y raised to power minus 4. There's minus here also. All the y equals 0. So minus x squared y over y raised to power 4 the s. So this will be plus x cube y4 minus y cube y raised to power 4. So one of this y we cancel this. We are left with minus x squared over y cube all the s plus we have x cube over y raised to power 4 minus 1 all over y. All the y equals 0. So that is the value we got. So having said that, the next thing is to show if this equation is exact. And now, for this equation to be exact, we know our partial m over partial y must be equal to partial n over partial s. Now, this is our m. The whole of this is our m, and the whole of this is our y. I mean, our n. The whole of this is our n. Now, let's differentiate this with respect to y. This is minus x squared dot y raised to power minus 3. And that will give us what? Minus 3y raised to power minus 4. So this is minus x squared minus 3 over y raised to power 4. So we have 3x squared divided by y raised to power 4. So if you differentiate this with respect to y, we are able to get 3x squared divided by y raised to power 4 equals. Now let us differentiate n with respect to s. Let's differentiate n with respect to s. Now there is no s here, so we are not differentiating this. So differentiating this with respect to s, we have 3x squared divided by y raised to power 4, which is the same thing with this, 3x squared divided by y raised to power 4. It shows that this differential equation is exact. And when our differential equation is exact, the next step is to when our differential equation is exact, we know our final answer. Our final answer then will be the integral of m, the s, plus the integral of n dy. N, sorry, without s. I always write it in a way that you understand. N without s, all equal to constant. Now let us integrate this with respect to s. Now, if we are integrating this with respect to s, we know our minus x squared will be a constant. So minus x squared is a constant. Integral of y, so this is 1 over y cube. The same thing as y raised to power minus 3, all the y. Or we are integrating with respect to s, I'm sorry. We are integrating with respect to s, integrating with respect to s. So if we are integrating with respect to s, that means our y cube is a constant. So we are left with x squared. So that will be x raised to power 3 divided by what? xn plus 1 all over n plus 1 for all n not equal to 0. So we have x cubed over 3. That will give us minus x cubed divided by 3 y cubed for this. So integrating n with respect to s, we have minus x raised to power 3 divided by what? 3y cubed. Yes. Plus, let us integrate n without s. Because there is s here, we are not integrating this. We are left with what? Minus 1 over y. Now, if we integrate minus 1 over y, we have what? Ln y. Ln what? Ln y. So we have minus, the minus we have here, we affect the positive sign. Now let me do it like this. We have minus what? Minus ln y, all equals c, which is the constant. So we have minus x cubed 3y squared minus what? Minus ln y, all equals c. So that's our final answer for this. Yeah, so this is another example on rule 4. Rule 4 of the homogeneous exact differential equation. Now, we are given this question. How do we show that this differential equation is homogeneous? Now, we can only show this equation is homogeneous by following the first example I gave earlier. Now, this is y cube. So our y cube will be t cube y cube minus, this is a constant, you write your 3, and this is s. We have t raised to power 1 s, and this is y squared. We have t squared y raised to power 2 for this. Now let's try for the other one. We have t here, s squared will imply t squared s squared, and for y we have t raised to power 1 y minus t raised to power 1 s and t raised to power 2 y squared. Now for this we have t raised to power 3 y raised to power 3 minus 3. From the law of indices, we have t raised to power 1 and t raised to power 2. So this will be t raised to power 3 sy squared. Plus, for this side, we have 2 t raised to power 3 x squared y minus t raised to power 3 as well sy squared. Now, t cube is common to both. We have t raised to power 3 y cube minus 3 sy squared plus 2 t is common here. T raised to power 3 is common here as well. We have 2 x squared y minus xy squared. Now, the fact that this is t cube and this is t cube, it shows that the equation is what? The equation is homogeneous. And if the equation is homogeneous, then we can continue to determine the integrating factor. And what's our integrating factor? How do we determine our integrating factor? So to determine our integrating factor, we know our integrating factor for homogeneous is 1 over ms plus ny. Now, what's our ms? Let's determine our mx by multiplying the whole of this by s. So let's determine our ms plus ny, and that will give us sy cube minus 3x squared y squared for this, plus the positive sign here. Let's multiply the whole of n by y. Don't forget, the first one here is our m and the second one here is our n. So multiply the n by y. We have 2x squared y squared minus sy cube. At the end of the day, we have sy cube minus 3x squared y squared plus 2x squared y squared minus sy cube. If you look at this, 2x squared y squared, 3x squared y squared. Now this is sy cube plus, and we have minus sy cube. So this and this will cancel out. We are left with minus 3x squared y plus 2x squared y, meaning our final answer will be minus s squared y squared. Because if you look at this, it's the same thing as saying minus s. Let me give you this. You should understand how this is negative, because this value are the same. This value and this value are the same. You have negative sign here, which means this is bigger than this. So at the end of the day, our value is minus x squared y squared. So our integrating factor then will now be 1 over minus x squared y squared. So that is our integrating factor. So after getting your integrating factor, you use your integrating factor to multiply each of these terms in the differential equation. And so that will give us y cube divided by x squared y squared. I'm multiplying because this is 1 over the value. That's why it's dividing. Minus 3xy squared divided by x squared y squared. For the first one, all the s, plus, look at the second one, 2x squared y. We have 2x squared y divided by x squared y squared. There's a negative sign here. There's a negative sign here that will later change to plus. We have x squared, xy squared, x squared, y squared, all the y. Am I making sense? Now, let's divide. We have y cube here and we have y squared. Now, this is our integrating factor. Our integrating factor will be used to divide all the terms according to what I said earlier. Now, if you divide this by this, our integrating factor will be used to multiply each of the terms. Now, it is in form of division because our integrating factor is 1 all over minus x squared y squared. If you look at this very well and you multiply it by y cube, at the end of the day, it will be y cube minus divided by what? X squared y squared. So that is why it is coming in form of division. Don't forget, your integrating factor will be used to multiply each term in the differential equation. So this will give us minus y, y cube here, y squared here. So we'll be left with minus y divided by x squared plus, for this, y squared will cancel y squared. So we are left with 3 divided by s, all the s. Yes. And for this, we have, this will be minus at the end of the day because of this negative sign. S squared will cancel S squared. We are left with 2 divided by y. Plus, this will cancel out this. We are left with 1 all over x, all the y. Now, let's show if this equation is exact or not. Now, for the equation to be exact, we know our partial m to partial y must be equal to partial n to partial s. Now, let's differentiate this with respect to y. If you look at this, with respect to y, we have minus y. We have minus y dot 1 over what? X squared. So if you differentiate this, we are going to have what? With respect to y, if you differentiate y, you have 1. So we are left with minus 1 all over x squared. So this will be minus 1 over x squared equals. Now let's integrate this with respect to s. So with respect to s here, we have what? We have 1 over x. If you differentiate this, you have x raised to power minus 1, right? That will be minus x raised to power minus 2. Minus 1 all over what? X squared. So minus 1 all over x squared. So the equation is exact. Now, since the equation is exact, then we can get our final answer. So for our final answer, we have integral of m ds plus the integral of n without s, all equals to a constant c. Now, if we integrate this with respect to s, I mean this first one, if we integrate this with respect to s, what are we going to have? It implies that our minus y is constant. Minus y is constant. Then integrate this, x raised to power minus 2. That will be x raised to power minus x raised to power minus 1 divided by minus 1. Don't forget we have minus y outside, and this will be y divided by s. So for the first one here, when we integrate s, we have y divided by s. Now, if we integrate this with respect to s again, we have plus 3 ln s. Plus, let's integrate n without s. So there is s here, we don't need this. But if we integrate this, it's a negative sign. Because of this negative sign, we have minus 2 ln of y equals to c. That's our final answer. Thank you so much for listening to my lecture. In the next class, we are going to explain second order differential equation.